So each network device, doesn't matter if it's a switch, a router, a firewall, an IPS even, but that's going to be less common. Let's speak in general about, let's say, routers, switches, and firewalls, which are the most commonly seen network devices pretty much in all networks. Otherwise, we have, of course, other network devices, but let's say from the numbering point of view, they are less frequent to be seen in the network as opposed to routers, switches, and firewalls. So each of those three main network devices have to begin with what is called the control plane. So their operation is being done through a couple of planes, like three in number, one of them being the control plane. Where the control plane identifies all traffic is going to be, I said in there IP traffic, but it can be non-IP traffic, as I said in the example. So it's going to be any traffic IP or non-IP initiated by the router or destined to the router. So it's not going to be traffic transiting the router. And the control plane traffic is being used by the router to learn information required for packet forwarding, which is going to be the data plane from the operation point of view. So for example, like protocols like ARP, like OSPF, BGP, LDP, PIM, and because packets are always destined to the router or initiated by the router, it means that all of those packets are going to be process switched, which means by the CPU of that specific device. So as I was saying, the main scope of the control plane, it is basically going to run some protocols, like those examples like ARP and routing protocols, and those protocols are going to facilitate the data plane forwarding capability. So if the router doesn't learn through routing protocols about destinations, if the router doesn't learn through ARP what is the IP to MAC binding, then the router cannot route packets back and forth. Next is going to be the management plane, which is just a subset of the control plane, because likewise in here we have IP traffic in general. In most cases it's IP traffic in here, which is likewise as in the control plane case, either initiated by the router or destined to the router. Please take note that I said in here router generically speaking, because as I was saying, this applies to pretty much all network devices. If it's a router, a switch, a firewall, or pretty much even other types of devices, all of them have this kind of planes in order to operate and perform their day-to-day job in the network. So the management plane is used, as the name states, it is used for remote inbound router or device management. Examples being CCNP, Telnet, SSH, NTP, TechX+, Radius, and so on. And likewise, because these packets, in order to manage the router, these packets are either destined to the router or initiated by the router, it means that packets are likewise always process switched by a network device. So all of the CCNP packets, Telnet packets, NTP, TechX+, Radius, all of them are going to hit the CPU and be processed by the CPU, because the router, the device has to intercept the packet, accept it, and open up the payload to see, okay, what is this packet for? Okay, it's for me, it's an OSPF packet. Let me open it up and see what's in that OSPF packet and use it to populate my routing table, for example. That was for the control plane packet. Or for the data plane packet, for the management plane packet, if it's, for example, TechX+, it means I'm going to receive a TechX+ packet destined to me as a router. I'm going to accept it, open it up, and see what's in there, and make use of it to authenticate users, or whatever I'm using TechX for. And clearly we have the last plane, which is a data plane, where it's going to be in the data plane we have in general IP traffic, because nowadays we speak about IP everywhere. It's very rare cases that we have non-IP traffic being routed, like for example IPX or AppleTalk or whatever else. So other layer 3, let's say, protocols. So data plane has to do with the forwarding of layer 3 protocols, which nowadays we speak about IP traffic. So because this has to do with the forwarding of the packets back and forward, it means that the traffic which belongs to the data plane is going to transit the router, is not going to be destined or initiated by the router. So this data plane identifies, it's going to in the end be the packet forwarding between the router interfaces. So that's the final goal of the router, to be able to route packets back and forth, or the final scope of a switch to be able to switch packets back and forth, or the final scope of a firewall to be able to, as long as the packet is being, it's allowed by security policies. Likewise, the firewall has to be able to switch the packets back and forth if it's deployed in layer 2, or route the packets back and forth if it's deployed in layer 3. And of course, data plane cannot work without control plane being functional, but of course can work without management plane being functional. So as I was saying before, if a router or a switch, or let's say a router or a firewall needs to find information how to reach IP destinations is going to be doing that through routing protocols. Once the routing protocols have done their jobs, then the next hop, the IP to MAC binding, is done by the R protocol. So those protocols are going to be packets which belong to the control plane. So that's why if the router cannot learn about destinations to routing protocols and cannot resolve next hops, then data plane can never work. So it makes sense that without the control plane, data plane cannot work, but without the management plane, data plane can work. Because the management plane of the router is only used to be able to remotely manage the router, monitor it, and also grab any statistics from the router to be used for other purposes, like for example for forensic analysis or incident management in the case of an attack. And packets that belong to the data plane, which are transit packets, are in general self-switched, which means those packets will be either hardware accelerated or software accelerated or assisted, depending on the platform we're speaking about. So some platforms, they do SIF in hardware, some of them they do SIF in software. So it all depends on the platform you're speaking about, where most of the high-end platforms, the modular platforms, are going to be doing the data plane. So packet forwarding is going to be done at SIF level in hardware. That's why they have better performances. Like you see a router which can route back and forth terabits per second. While if this is being done in software, which is the case for smaller routers like it's the ISR G2 series, then that's why on those routers you see smaller performance in the range of hundreds of megabits per second, or close to maybe 1 gigabit per second on the bigger devices. Because these routers do SIF in software, it's CPU assisted somehow. They don't have dedicated ASICs to do SIF switching or SIF packet forwarding. But even in the case, so ideally the data plane packets will be in general SIF switched for performance. That's how we achieve huge performances on the routers that do everything in hardware, that they can achieve terabits per second forwarding throughput, as opposed to other boxes that don't have the hardware option. Either way, even if most packets in the data plane will be somehow self-switched, if it's hardware or software, doesn't matter. If in the end most of them will be self-switched, there are some use cases where the data plane packet is also going to be process switched. I gave that just one example in there. When the router needs to fragment the packet, then because the fragmentation of the packet has to be done by the CPU, because the CPU has to realize, okay, the packet that came in size 200, the egress interface MTU is I don't know, 500 or whatever. So let's say that the ingress packet size was 1500. And then egress interface MTU size is 1000, so 10 hundredths. So in that case, the router has to split the packet into two, but that has to be done by the CPU. So in that case, even if that packet is a packet transiting the router, it's not destined to the router, because the router has to take some action on the packet, except other than switching it back and forth or routing it, it has to fragment the packet. That cannot be done in Ceph. It's going to be done at the process level, at the CPU level. So at that point, that specific packet will not be self-switched, it is going to be process switched. So you have to in generally identify whatever the network devices you're working on. You have to be aware of those protocols, because you're going to have specific tools to defend against attacks to any of those planes. Because as you're going to speak next, you're going to have specific tools to defend against control plane attacks, against data plane attacks, against management plane attacks. And likewise, you have to understand what is the architecture of that specific network device, because some devices, for example, some devices make a clear difference between those three planes. Other devices from different vendors, they somehow put everything into, like, put the control plane and a management plane into the same plane, for example. So it can vary between vendor and between each vendor's equipments, but in the end those three planes exist on all devices. It's just a matter that if they are treated individually by that specific device, or somehow two of them, like in general the control plane and the management plane, are treated as a single, let's say, plane, not as two different planes.